Hey, Trig class. This is the first part of section 10.6. This, I think, is the last section of the chapter, but I'll separate this into two different videos just to kind of make it a little bit shorter. I kind of sound a little congested because I've kind of got a little bit of a head cold. My nose has been running, so I apologize for that. I promise it's not coronavirus. That's not a symptom of coronavirus. I don't have the cough and that whole bit. It's just the runny nose. So, if you've come into contact with me since we've been out of school, I promise you're fine. So, 10.6 applications of vectors. This is what you guys probably did a lot in physics, if you've had physics already, but this is like why, the whole reason why vectors are even used, okay? So I'm going to start us off. The first part of this video is just going to be kind of the math behind, the story problems, and then we'll get more into the story problems in the next video. So I'm going to switch this first example because I didn't like it very much. I'm going to change it and say find the component form of a vector with a magnitude of 6 in a direction of 90 degrees. Okay. I made this problem up, so go ahead and change that on here. We're gonna figure out what the component form is. Okay. So component form, if you remember from the last couple videos, component form is that like triangular bracket form, okay, where this basically tells me left or right, and this guy tells me up or down, okay? So that's what each one of these coordinates tell me, and they're basically saying, tell me what this thing will look like if I'm going 6 units at a 90-degree angle, okay? Now some of you guys probably know in your mind what this will look like, but I'm going to relate this back to polar form that we had before, okay? So in section 10.3, I think, we had something like r equals cosine of theta plus I times sine of theta or whatever, okay? Something of that nature. And this is going to really relate really close to what the component form is, okay? I told you that switching from polar form to rectangular form, you would just multiply stuff together, and so I'm going to kind of show you what that looks like. When your magnitude is 6, that's basically what your r is. Okay, so I'm plugging 6 in for the radius of what would be my circle here, and then cosine of 90 degrees, sine of 90 degrees. Okay, so this is polar form, and we want to go to rectangular form. Okay. And rectangular form would be like that component form, okay? Okay, so if I take this 6 and I distribute it through, 6 times cosine of 90 degrees, all right, if I do that in my calculator, then you might be able to do this in your head, 6 times cosine of 90 degrees. Okay, think about what cosine of 90 degrees is. Cosine of 90 is going to be 0, and 0 times 6 is going to be 0 also. Okay, so this first coordinate is going to be 0, okay, and then I'm going to do the same thing for 6 times sine of 90 degrees, okay. If you think about what sine of 90 degrees is, sine of 90 is going to be 1, okay, because on the unit circle, sine of 90 is that y coordinate, so up at 1 times 6 will be 6, okay. So rather than writing it with a plus sign, though, they'll have us write it in rectangular form as 0, 6, okay. So this is what you will do when you're trying to go from magnitude and direction to the component form, okay? And this really kind of makes sense. Find the component form of a vector with a magnitude of 6 at a 90-degree direction, okay? So thinking about what my angle will look like. If I'm going in a 90-degree direction, that means I'm going straight up in the air, right? 90-degree direction would be from here to here, and I'm going up 6 units, right? That will land me at the point 0, 6, okay? So this was a fairly easy example on your homework assignment. I think they have you do like a 60-degree angle or a 225-degree angle, but that's all that means is that, it's the same process that you do before. It's just going to, or the same, you're still going to distribute through and you're still going to find cosine and sine of that angle. It's just going to give you something that's not quite so nice. You might end up with decimals, and that's fine. They will write the magnitude with those double line brackets. So this means the magnitude here is 5. So you're going a length of 5 units, whatever that is, at a 60-degree angle, okay? So that's kind of that first part. And then sometimes instead of using sine and cosine, they will use I and J instead, okay? So I you can kind of think of as the cosine or the x coordinate. J is going to be the sine or the y coordinate, okay? And so what they're demonstrating down here is that you can take component forms and you can add them together, which I think we did in the last section. So 5, 0, this would mean to the right 5 and 0 up. You can add that to going 0 units left or right and 7 units down. And what that would look like is, well, it'll look like 5 comma negative 7, which is like 5 times 1, 0, and 7 times 0, 1, okay? Because they designate I and j to be those vectors. But anyway, it will just end up looking like 5i minus 7j, which is kind of taking into consideration that polar form. Okay, so 5i negative 7j, sometimes they'll write your vector form instead of component form like this. They'll write it as 5i minus 7j. Okay, so this guy, if I were to write him, he would really be like 0i minus 6 or plus 6j is what he would look like in I and j notation. So this is just alternate vector form. Sometimes they will have you write it like that. Okay, so they want us to do this here. They say perform the operations. You have 2i minus 6 and negative 5 plus 2. They want you to take 3 times u and subtract 2 times v, okay? So if you're one of those people that likes to write this in component form, we can write this as 2, negative 6, and this guy as negative 5, positive 2, okay? And now he's in component form again. And they want me to take 3 times u, so I want 3 times this guy, minus 2 times that guy. Okay, that's what they're wanting us to do. So let's go ahead and distribute. This is my scalar multiplication again, and then I just have my addition from there or subtraction from there. So distribute the 3 through just like you would do anything normal. This would be 6, negative 18. Okay. Minus, I'm just going to distribute the 2. Okay, if you want to distribute the negative with the 2, then this could turn to plus sign. It doesn't matter, whatever you want to do. I'm going to leave it as minus, and I'm going to do 2 times negative 5, which will be negative 10. And 2 times 2 is 4, and then I'm just going to put those two guys together. All right, 6 minus a negative 10 is going to be like 6 plus 10, or 16, comma. Negative 18 minus 4 is going to be negative 22. Okay, so that's what he's going to look like if we want to put it back into the I and j form. This will be 16i minus 22j. We could have left it in the ij form. It doesn't matter, you know, whatever route you want to go. If you want to leave it ij form and multiply and distribute, that's fine too. But I switched it to the vector form or the component form because that's what my brain's kind of thinking of. Let me blow my nose. Hold on. Okay. Now they're going to give us a little bit of a story problem, not really doing a whole lot yet with this, but they want us to find the component form of the vector that is represented by this, basically this vector that's going on here, okay? So that's all they want us to do is component form. So our final answer is going to be like this, okay? And to get it to that point, I'm going to go kind of reference back into example 1. The two things that we need to know if we're going to write a vector in component form is we need to know the magnitude of that vector, so how long is it, okay, and we need to know the direction that it's going, how angled is it, okay. So we look down here, we need to know that its magnitude is 60, so they'll write that like this. They'll do like a double bracket thing here. It is 60, maybe 60 miles. Okay, so 60 miles is how far that's going, and then the direction is 7 degrees. Okay, so by finding this component form, this x and this y, basically we're saying, okay, if you go 60 miles at a 7-degree incline, you're going to end up right at that dot. But in component form would be the x that would get me from here to here and the y that would get me from here to here, right? So it's like alternately I could go this way and then up this way, and how far would I have to go in each one of those directions in order to get me to that exact spot again? That's basically what we're trying to find, okay? So I'm going to kind of go back to that polar form where we had r, it was cosine theta plus I times sine theta, and then you just plug your stuff in, okay? So your R is going to be that 60, okay, because that's the distance that I'm traveling, and I'm going a direction of 7 degrees and 7 degrees, okay? So all I'm going to do is distribute that through. So if I do 60 times cosine of 7, 60 cosine of 7, that will give me 59.55, okay? Or 59, we'll go one decimal place, 59.6. So that would mean that I'm traveling in the x direction, 59.6. Okay, and then I have to figure out how far I'm traveling up. Probably not going to be very far up because I'm only going 7 degrees, okay? But that would be 60 times sine of 7. Okay. So 60 sine of 7, and that is 7.3 feet, or no, miles, 7.3 miles, okay? So that's what my component form is going to end up looking like. It's kind of like taking that polar form and transferring it back into rectangular form. I'll write that down here, polar form, and then we're going to rectangular form. Okay. So when you go from polar form to rectangular form, that I kind of goes away, the plus sign really changes into a comma, but it's kind of listing them as like a coordinate pair instead, okay? All right, so we're going to start doing computations with story problems. So this wasn't a terribly advanced story problem. They're going to have like 2 vectors going on at the same time, but it'll be a piece of cake. So last thing, find the direction angle of each vector. Okay, so now they're giving us component form, okay, and we've already done this before. 5 plus 13j means that we're going 5 right and 13 up. Okay, you've already done this before, okay? So if you want to think about it, this will be 5 and 13 this direction right here. Okay, so it'll land me somewhere like this, and I'll have a triangle that looks like this, where this is 5 and this is 13, okay? All right, so I want to know what the direction angle is of the vector. So basically, what is this angle right here, okay? And I could find that hypotenuse, okay? The hypotenuse is not 12. It's not 5, 12, 13, because look at where the 13 lives. The 13 is actually here instead of here, okay? So don't get that confused. This would be like the square root of some ugly number. But we really don't care about what that hypotenuse is, because if we have these 2 sides, we can figure out what this angle is, okay? And we do that by using a trig function. So if this is my angle theta, I have 13 as opposite, 5 is going to be the adjacent side, okay? And that's going to give me tangent. And you'll find that there's kind of a common theme here, that when you're given the x-coordinate and the y-coordinate, you're going to always end up using tangent, okay? So what we're doing is we're using tangent of angle theta will give me opposite over adjacent, or 13 over 5. And then I would just have to find inverse tangent to solve for that angle. So inverse tangent, and I just plug it in. Inverse tangent of 13 over 5. And that is 68.96, or let's go 69.0 degrees. Okay, 69.0 degrees is how big that angle will be, okay? All right, now in part B, it's just going to be ever so slightly different. This would be the components -10, 7, which means 10 to the left and 7 up. So if I draw out what he looks like, 10 to the left, whatever, 7 up, he'd be about over here somewhere. Okay, if I draw my triangle looking like that, 10 to the left, this will be -10. And 7 up will look like this. Okay, now this one's going to be just a slightly trickier, because if this is my angle theta, I still have opposite and adjacent, so I'm still going to use tangent, except if I do tangent of theta, I will end up with 7 over -10, and I'm going to type that in my calculator, but it's going to give me a funky answer, and we've really done problems like this before, but inverse tangent of 7 divided by -10. And he is -35.0. Let's say -35.0 degrees. It's negative because tangent in the second quadrant is negative, but this guy is 35 degrees. Okay, that angle is 35 degrees. But I don't want to know that angle. That would be like the reference angle, right? Reference angle. Okay, so if I have a reference angle of 35 degrees, I want to know from standard position. So I'm going to use my other color here. From here all the way over to here, what would that angle be? How far would that angle be? Okay, so remember, from here all the way to the other side would be 180. 35 degrees would be this guy. I'm trying to figure out what this one is. Okay, so I would really end up taking 180 minus that 35 degrees, and that would give me 145 degrees here. Okay, so that's what my actual angle is going to be. Find the direction angle of each vector. The reference angle would be 35, but 145 degrees is the one that I actually want. Okay, so if you have an angle in the first quadrant like we did for part A, you don't have to do any of that addition, subtraction, anything like that. But if it's in the second quadrant, third quadrant, fourth quadrant, you will have to add or subtract or do something funky weird to figure out what the angle actually is. Okay, because if you just tell me 35 degrees and say that that's the answer, I'm going to think 35 degrees is this angle in the first quadrant. Okay, so you have to subtract that in order to show me that it's actually 145 degrees, so it's in the second quadrant and not this one. Okay, all right, so we're going to stop there. We have 3 story problems for the next video, and there we go. Oh, that should get you to, I think, on the notes or on the homework, you should be able to get through 1 through 6 on there. Okay, I might cut some of these story problems down so you have less to do next time, but do all of them 1 through 6. Okay, don't submit this to me until we are done with part B of this video. Okay.